It's time to get high with a dose of math. In this very first video of mine, we'll explore the oldest algorithm that survived the present day, the Euclidean algorithm. Its widespread application in cryptography alone can justify its importance today. The Euclidean algorithm calculates the greatest common divisors of two numbers. I will first explain what is meant by the greatest common divisor. Then I will implement this algorithm on Microsoft Excel. If you are familiar with greatest common divisor, you can skip the first part. So we have two numbers here, 24 and 16. And also all their factors listed out. There are some common factors, in other words, common divisor. They are in green. So the largest of them is the greatest common divisor, which is 8. For numbers like this with small factors, you can use trivial methods like factorization to figure out the greatest common divisor. The problem comes when the factors are large, such as this pair of numbers, but not for the Euclidean algorithm. The Euclidean algorithm employs division with remainder. When we first taught the concept of division, we were told to leave the remainder alone. If you divide 30 by 7, you get 4, remainder 2. The remainder is what we are interested in now. The Euclidean algorithm repeatedly calculates the remainder until it gets 0. We now implement this on Excel with equations. So when the dividend 45333 is divided by the divisor 10,001, what's the quotient and what's the remainder? A direct division will give a result of 4.53. So we only need the quotient. Let's round it down to 4. We now calculate the remainder. There's this modular function that does the job. There you go. We can check that this equation is true. We call this an algorithm because it can be repeated or reiterated. So the divisor is now the dividend, and the remainder is now the divisor. And similarly, we calculate the quotient and the remainder. You can check that both of these equations are true. We repeat until we get the 0 as a remainder. There you go. The greatest common divisor of 45333 and 10,001 is 73. Here is a rough idea why the Euclidean algorithm works. The GCD of the dividend and the divisor, which is what we are going to find, is equal to the GCD of the divisor and the remainder, which becomes the dividend and the divisor respectively. And this repeats until you get the remainder becomes 0. So let's try when a pair of numbers 1, 2, 3, 4, 5, 6 and 6, 5, 5, 3, 7. The algorithm isn't complete, so we need more lines. Let's copy and paste, 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 0. So there you go. The greatest common divisor is 1. We call this pair of numbers co-prime. They have no common factors other than 1. You can download this file and try out other numbers. The algorithm is used anywhere in your computer where a GCD is computed. I will explain how it is used in cryptography in the future. You might notice that the quotient is ignored in the computation of the GCD, but it will be used in the next video where I explain the extended Euclidean algorithm. Signing off, this is a dose of math.